Okay, now that we spent all this time learning the rules of factoring and how to factor, now in all the modules that are following, you're going to learn why we needed to learn how to factor. We're going to use factoring a lot in simplifying algebraic expressions. Our next set of modules have to do with the topic of rational expressions. So we're back to understanding vocabulary words. The word rational means fraction. Every time you hear somebody say rational, you want to think of a fraction. The word rational has embedded in it the word ratio. And if I said the ratio of men to women in the room is 1 to 3, your first thing would see is a fraction. So a rational expression is an algebraic fraction. It could have a polynomial in the numerator. It could have a polynomial in the denominator. So that's when you hear the word rational. I don't want you flipping out. Every time you hear the word rational, you're to think fraction. This whole next module is all about operations of fractions. We are going to be working with fractions. Okay? In your PowerPoint, here are some examples of rational expressions. 2/3 is a fraction that you're used to seeing. That is now called a rational expression. It has a monomial, a constant in the numerator. It has a constant in the denominator. Negative 4x over 6 is a rational expression. It has a numerator, negative 4x. It has a denominator, 6. A plus 6 over a squared minus a minus 6 is a rational expression. That is truly an algebraic fraction. It has a binomial in the numerator and a trinomial in the denominator. So that's what this next set of modules is going to be about, dealing with fractions. Instead of the fractions just having numbers, they're going to have variables. Okay? Everything we do in this module goes directly back to arithmetic, what you learned in elementary school. So the first thing I want to make is when you write a rational expression, we know we never leave the negative sign in the denominator. That negative sign we've talked about has got to float to the numerator at the top. So it's important when you're writing these rational expressions, number one, you're using the fraction bar that goes across. You're not using a slash. You're using a fraction bar that goes across. And when you write your rational expression, your denominator, if it's a monomial, one term, should be positive. So if there's a negative sign, it's got to float to the top. So if you write 2 divided by negative 3, that rational expression is written incorrectly. We will accept either you float the negative to the middle of the fraction bar and you write negative 2/3, or like I prefer, you actually float the negative to the numerator and you write negative 2 divided by 3. I want to make sure you understand why there cannot be a negative sign in the denominator of a fraction. The fraction bar means the operation division. And division means breaking in groups. Pretend I had $10 and I wanted to divide that into 2 groups. I could do that. Each group would get 5. If I had $10 and I divided it into 5 groups, I could do that. Each group would get 2. If I had $10 and divided it into 10 groups, I could do that. Each group could get $1. But if I had $10 and said divide it by negative 2, that makes no sense. You can't take $10 and divide it into negative 2 groups. The denominator of a fraction is called the divisor. And the divisor, what you're dividing by, should always be a positive whole number. So that's why when we write rational expressions, fractions, that negative sign's got to float to the top. Why can we have a negative in the numerator? Because think about it. I can lose $10 and divide that among 2 days. So negative 10 divided by 2 makes sense. If I lost $10 and I divide that among 2 days, that means I lost $5 per day. So the numerator can be negative, just never the denominator. So don't be afraid when I start talking now. Instead of saying fraction, if I say rational expression, that's just your fancy word in algebra for fraction. Okay, I'll see you in the next video.